Alright, you guys, so today's essential question is, how do we write a factored expression? So I'm going to do a definition, and we're going to do the components of a factored expression. So what does it mean to factor? Factoring basically just means pulling out terms or dividing by a term. Okay, to divide a term or expression. So you can factor a number, you can factor a number with a variable, or you can factor a full expression. So when you factor an expression, you get a number on the outside, let's say like 5, and you get some numbers on the inside, 4x plus 2. Okay, well, actually this should be like 4x plus 1. Okay, this number on the outside is the term, or this is the number that we could divide by. This is the divisor. Okay, this is what we factored out. This is the greatest common factor, the GCF. Okay, this stuff on the inside is what was left over afterwards. It's the remainder. It's what we couldn't divide anymore. Okay, so you'll notice that a factored expression looks a lot like what we start with when we have a distributive property problem. So factoring gives us distributive property problem. So factoring gives a distributive property problem. So it looks like distributive property. Okay, so we're going to start with example 2, which is factoring an expression with variables. All right, the expression we're going to start with is 4x plus 20. Now I've been doing this with the ladder method, but I just want to just reiterate how to do it if you don't want to do the ladder method. So if you don't do the ladder method, you can write the two terms above each other and then write their factors. So I know that 4x, 4 times 1x, or 4x times 1. I know 2x times 1 times 2, and those are all the factors of it. I know 20 has the factors of 1 and 20. It's got the factors of 2 and 10, and it's got the factors of 4 and 5. Okay, now you'll notice that on this 4x term, I made sure that each factor pair had an x value so that I don't forget about the x, because it's got to stay, it's got to hang out at the very end. Okay, so then now I'm going to circle common terms. So I'm going to notice that 4 is shared between the two of them. I'm going to notice that 1 is shared between the two of them. And I'm going to notice that 2 is shared between the two of them. Now you'll notice I didn't circle 1x, 4x, or 2x because they have x components and the 20 doesn't have an x component. Okay, so their common factors are 1, 2, and 4. What's the greatest of those common factors? The GCF. The GCF is 4 because that's the biggest number that they share in common. Okay, now another way to do that is you could factor using the ladder. So then I say, okay, well, 4x and 20 are even, so they can be divided by 2. And then I get 2x plus 10. I know 2x and 10 are both even again, so I divide by 2 again. And I get 1x plus 5. Okay, and then 1x and 5 are both prime numbers, so I can't do anything else, and I use these two to find the GCF. So the GCF equals 2 times 2, which equals 4. Notice either way gets me the GCF, but if I do it with the ladder method, then I also can easily find the component that goes inside, or the remainder. Okay. So if I want my expression to look like this one up here, the ladder method is an easier way for me to find the new expression. So 4x plus 20, that's the original expression, is equivalent to or equal to the GCF times the remainder down here, 1x plus 5. Okay. So while you can factor using factor pairs, it is easier if you do it with the ladder method, which is why I do it that way.